Welcome everyone to this video on Open Container Initiative, or otherwise known as OCI. Let's look at what Open Container Initiative is. Open Container Initiative was established back in 2015 by Docker and few other leaders in the container industry, including companies like Google and Red Hat. It is governed by the Linux Foundation, and the goal of the initiative is to build open standards around container technology. Let's try to understand why open standards was required. Back in 2014 to 16, we saw a lot of container adoption. Many companies were experimenting with container tools, and some of them were implementing their own tools. Although these tools were addressing some of the issues that there were in the existing tools, there was a slight problem. These tools were working in kind of silos. Each of them had their own way of implementation and own way of execution. In other words, there was no interoperability among these tools. Let's try to look at this from an end user perspective. As an end user, once I choose to go with a particular tool, say X, it would be difficult for me to replace tool X with tool Y in a future date. Or in other words, I would be in a vendor locked in scenario. Engineers from many companies who are working with container technologies understood that this is an issue for the whole container industry and realized the need for standards. Not just standards, but open standards. As a result of the standardization process, currently OCI consists of three specifications, namely the image specification, the runtime specification, and the distribution specification. The image specification defines the image format, and the runtime specification standardizes the mechanism to run an OCI image, and the distribution specification standardizes the API to distribute container images. Let's try to understand what Docker has to do with OCI. When the initial standardization process began, Docker had already become the de facto standard for containers. Docker generously donated its own image specification as the basis for the image spec, its own runtime component runc as the basis for the runtime spec, and the Docker registry specification as the basis for the distribution specification. All these contributions became the foundation of OCI. Let's try to understand how interoperability is achieved through a graphical illustration. On this particular example, I am using two tools, Docker and Podman, to build and run container images. Let's go through the first option of using Docker to build a container image and then running it. Docker build would output a Docker image, which then I could run using docker run command. Similarly, I could use Podman build to build a container image using Podman toolset and then run it using Podman run. One important thing to note here is that both images built using Docker and Podman are OCI compliant. Since Docker and Podman knows how to run an OCI image, an image built using Docker could be run using Podman, and an image built using Podman could be run using Docker. This is what we mean by achieving interoperability. What this also means is that once an OCI image is hosted in a container registry, any OCI compliant tool can be used to pull and run these images. I hope this video has helped you to understand OCI and how its standards have helped interoperability among container tools. Thank you.